Dear students, in this video session, I am starting the new chapter, Boolean algebra. This is the second chapter in our computer science syllabus. So before this, in the last video session, I have completed classes and objects. So classes and objects completed in the last video session. Before this, we have seen loop concepts, and before that a review of C++. Okay, so this is chapter number 5, 6 and this classes and objects is a 7th chapter. So this is about the C++ unit. Okay, this is second unit, and before these three chapters, before the lockdown, I have completed the chapter 1, typical configuration of computer system. So this completed before the lockdown itself. Now the second chapter is the Boolean algebra. Third one is the logic gates. Fourth one is data structure. So these four chapters coming under first unit, and it is of a backdrop of computers. Okay, so backdrop of computers. There are around 4 chapters. From the 5th chapter till the chapter 12 is about C++ unit, second unit, and of course we are having 2 more units. Third unit we are having chapter number 13 and 14. In the 4th unit we are having 3 chapters, 15, 16 and 17. So third unit is about the database relevant, and the last unit, 4th one, there we are having 3 chapters. It's about communication technology. So we have completed 3 here in the C++ unit. We'll take break from this unit. We'll move back to this first unit. Okay, there, okay, this one we have completed, we have seen before the lockdown. Now I am going for this Boolean algebra. So this Boolean algebra is about 10 hours chapter and having 9 marks. So 10 hours and 9 marks. And here, after this Boolean algebra, before taking any other chapter, I will take this logic gates. Okay. So soon after Boolean algebra, compulsorily I will go for the logic gates before any other chapter, because these 2 chapters are relevant to each other. And in other way, I can say in our syllabus, logic gates is an extension topic of Boolean algebra. So this logic gates is of 5 hours and it is having 4 marks. So both together, Boolean algebra and logic gates is about 15 hours, and they fetch 30 marks in the main exam. So after Boolean algebra, compulsorily I will go for the logic gates. And here in the data structure, in one of the video session I told you we are having some CBP programs for the practical purpose apart from this C++ unit. So in the C++ unit and from the data structure unit, overall we are having 16 C++ programs for practical purpose. From the data structure we are having, from this particular chapter of first unit, okay, so we are having 9 C++ programs for the practical, and from this C++ unit, from chapter number 5 till 12, we are having 7 C++ programs for the practical. So even these 9 CPP programs of data structure, for them also we require the concepts of the C++, whichever we are studying here from chapter number 5 to 12. So these concepts we are using, and in this data structure, and here we are having some problems. For them also we have to write C++ programs. So from here we are getting 9 C++ programs. From this C++ unit also we are getting 7 C++ programs for the practical. Overall we are having 16 C++ programs for the practical. So this is section A. Okay. So still we have some practical experiments from this chapter 14, from the third unit, from the 14th chapter called SQL. From this chapter we are having 4 problems, or you can say 4 experiments. In the same way, in the last unit, last chapter, from the 17th chapter, which is the chapter name is Web Designing. From this chapter also we are having 2 experiments or 2 problems. So this is section B and this is section C. Okay. So overall 16 plus 4 plus 2, 22 experiments you can say. Out of 22 experiments, 16 C++ programs, 14 SQL relevant experiments, and 2 are from the web designing chapter, in the 4th unit, last chapter 17, web design. So in the last year also we had 2 programs on web designing. It's about biodata, writing HTML program for the biodata and HTML program for college website. So 2 programs we have seen in first year. Here also these 2 programs are of HTML. Okay, so we have to use some tags. Of course, the tags which we are using in first year, in them also we are going to use some HTML tags. Of course, few are compulsory, and additional tags we are going to learn in this chapter. So based on that, we are having 2 programs, 2 HTML programs. So these 4 which are on SQL on chapter number 14. Here we are having some 4 problems. They are something like the one which we have done in first year, Excel sheet experiments. So ESS, electronic spreadsheet. So there we have seen some problems like sales representative and calculating the marks of students, calculating the salary, where the salary is calculated with the values of basic salary, TA, DA, etc. So those type of problems we have taken and we have solved by using Excel sheet. Okay, those problems almost of same type. Here we are solving them by using SQL. Okay, so later on we'll see what about this SQL. So from there we are having 4 problems. So for them we are going to write, you can say SQL small programs, which we are calling them as queries. So anyhow, this is about your practical relevant experiments, 16 C++, 4 of SQL relevant, database relevant, and 2 of HTML programs. So here it is about your second year computer science syllabus. We have completed this review of C++, OOPS concepts, and classes and objects. So some chapter number 5 to 12, it is about C++ unit. Okay, so this typical configuration of computer system is completed. This is a Boolean algebra, is of 10 hours syllabus or chapter and 9 marks. So then the logic gates, I am going to take this logic gates before any other chapter, and this is the data structure. So from this we are having 9 CPP programs for the practical, and from this C++ unit we are having 7 programs. Okay, so here this is the third unit, the database unit. 2 chapters are there. From this SQL we are having 4 practical programs. So the last unit is about the communication. We are having 3 chapters. in the 17th chapter web designing, from here also for the practical we are having two programs, HTML programs. So this is about your section A, C++ programs, that is from C++ unit and from this data structure chapter. Overall 16 are there. Okay, so here starting 5 and the last 4 are from the data structure. So from the data structure chapter these programs are taken. So from the C++ unit it is about from the 6th to 12th. 1, 2, 3, 4, 5, 6, 7. 7 are from CPP unit. So overall 16 programs. Okay. So 6th one I have already explained to you people. It's about the simple interest program wherein we have to create class, thereby objects, and the member functions we have to create. This one I have already explained in one of the video session. Okay, so since because of this lockdown I have not given the record books to you people, so that's why what you can do, you pause this video and you can take this screenshot of this one. Okay, this is the section B. These 4 problems are taken from the SQL commands, 14th chapter. Okay, from this. So from this SQL commands we are going to have these 4 problems in the section B, SQL. Okay, so as I told you, it's all about the storing the data. So as we have seen the Excel sheets in the last year, this time we are going to use SQL to store the data, to calculate some values, okay, in a table, okay, which is having rows and columns. Anyhow, the last section C is about the web designing. Okay, this last chapter. From this we are going to write 2 HTML programs. An HTML program for creating study timetable. Of course we are going to use some new tags here apart from the tags which we know already from first year. And this is the last one more HTML program for creating form including with table. Okay, so this is about section B and section C, and it's about practical exam. So you are going to have 2 questions, one from section A, C++, and the other question you may be having either from section B or from section C. Means you may be having the second question from the SQL from this, or you may be having from this as an HTML program. So first question is compulsorily on C++. Okay, compulsorily on C++. The second question it may be either from this section B or from this section C. Overall 2 questions. Okay, so for writing both you are having 12 marks, for execution 6 marks, for output 2 marks. Likewise you are having this 30 marks. So here also you can take the screenshot of this one for your reference. Now coming to our topic, Boolean algebra. Okay, so this is chapter number 2 and it is also called as switching algebra and algebra of logic, or we can say logical algebra. So here in the right side I have written some introductory part about the Boolean algebra. On the left side those are some terminologies. Those terminologies we should know for this Boolean algebra chapter. There you can see the name Aristotle. We all know this person. He is a Greek mathematician or scientist. He is the person who worked on formal logic. And so according to the records, he is the first person who worked on this logics. Okay, so first person who worked on this logic, and it's about around 2300 years back. Okay, so around 2300 years back only this person worked on this logical system. So thereafter, in the 19th century, okay, after a long gap, in the 19th century, the person called George Boolean. See, he again worked on this logics, and even he has seen the principles set by this Aristotle, and he continued work on that logical system, and then he has given the relationship between the logic and mathematics. So it is known as Boolean algebra. So because of his contribution in this particular branch of mathematics, his name is used. So his name is used and it is given as Boolean algebra. So here BOOLE, this particular name is used here as a Boolean algebra. It's all about his contribution into this field. So this particular type of mathematics, or you can say branch of mathematics, of course, we all know that algebra itself is a branch of mathematics. Boolean algebra, we can say it's a branch of algebra. So this particular section named as Boolean algebra, though there are some other names called switching algebra and logical algebra or algebra of logic. Oftenly we are going to use this name only, Boolean algebra, because of his contribution into this particular branch of mathematics. Here, this person in the 1854, he has written a paper called An Investigation of the Laws of Thought. Okay, so after that, it remained in the paper till this 20th century. Okay, so this George Boolean is in the 19th century work. So after some gap again, in the 20th century, this person, Claude E. Shannon, wrote a paper called A Symbolic Analysis of Relay Switching Circuits. Here, in this particular paper, okay, a symbolic analysis of relay switching circuits, he has applied this Boolean algebra for switching network, telephone switching network. Of course, it's not about the mobile phones which you are using now. It's about the landline phones in that period. Okay, in 1938 or around 40s, landline phone. There, of course, as we do in mobile phones, when we dial a number, it has to be connected to the other person. Then only we can talk to them. So in the telephone, normal landline phone system, it's about wired system. It's not about wireless. So when a person dials a number, okay, so when he dials a number, it has to be connected to the other person, wherever he may be. It may be of some tens of kilometers to hundreds of kilometers. So when he dials a number, it has to be, a connection has to be established to the other person telephone device. So all the way, it's about a kilometers of distance. So connection has to be established before the communication. So when the connection has to be established all over the path from source to say destination, it has to go through several switchings. It has to take place several switchings to establish a connection from source to destination. So here in the switchings, he has applied the Boolean algebra. So after the connection establishment only, these two people can communicate to each other. So here he has applied the Boolean algebra in the relay system and the telephone switching networks. So after this, what happened? Boolean algebra applied to computers. So what we can say, after his work, Claude E. Shannon work, so he has applied the Boolean algebra for the solving the problems in telephone switching networks. People realized, particularly the computer engineers or the scientists realized that the Boolean algebra could be applied to even computer systems also. So not only computers, it is actually about the electronics systems, or you can say digital systems. So people realized. So Boolean algebra is having a great impact for the digital devices or electronic devices. Mainly we are talking about these computers. So because we know the computer is also an electronic device. So computers, we know from the first year, since it's an electronic device, it can understand only two things, or you can say two values. So we know that they are zeros or ones. So it understands only these two, computer being an electronic device. So what about this Boolean algebra? This Boolean algebra also deals with only two states. So what are those? True or false. Okay. And whereas the computer or any electronic devices, they can understand only two states, zeros and ones. And in first year, so many times I told you, actually these zeros and ones for the computer system, which is an electronic device, for him, it is actually the voltage differences. So high volts and low volts, only two states, not about various volts. Okay, so only it can understand two states, high volts or low volts. So we can connect that something like high, low volts, and even I told you several times, high volts means around nearly plus 5 volts, low volts means low voltage is near to 0 volts. So here in the computer, it can understand only two states of voltages, high, low, or near to 5 volts is actually considered as high volts, near to 0 is actually considered as 0 volts. Or else you can say electric charges, presence or absence, okay, presence of volts or absence of volts. So by this way, computer, finally we can say, we can identify these two states by simply using two numbers, 0 and 1. So or we can say these are the two symbols we are using for our convenience sake. It is not about the 0 and 1 exactly those two values for the computer. It's about voltage differences for the computer. So nearly 5 volts one state, near to 0 volts is other states. So instead of saying all these things, high, low, presence of volts or absence of volts or on, off, so we are using simply these two numbers, or we can say symbols, 0 and 1. 0, 1 for high volts, 0 for low volts. So when it comes to Boolean algebra, it's all about logic. So in a logic we are going to see about only true or false. There also it is about only two states, okay, true or false. So oftenly instead of using true and false, again we can use this number system, 1 and 0, okay. So because of this, Boolean algebra can be applied to electronic devices. So there are also two states. In the logic also, in a Boolean algebra also, we are talking about only two states, true and false. So finally we can say both are having similar nature. Okay, that's why Boolean algebra can be applied to computers. So 1 and 0 means here in the logics it's about true and false. When it comes to electronic device, it is voltage difference. Okay, so by this way, easily for our convenience, we can use 1 and 0, whether it is this side Boolean algebra or at this electronic side. So 1 and 0 we use to mean either this or that. So because of this similarity, Boolean algebra can be applied to computers in processing. So every task in a computer, we know it is done by the processor, the processing unit. So wherein we can say the transistors are used. In first year we have learned the generations of computers. In the first generations of computers, what includes from second generations to till now, we are using transistors only. So where it identifying only two states, high volts or low volts. It's about zeros and ones when the processing is taking place. Of course, the electronic device, it can understand only two states, not only the processor, all the components of computer. So it's about only the signal difference, high volts signal or low volts signal. So anyhow, now we came to know that Boolean algebra can be applied to the computers. So further, Now we'll go for the some terminologies. So there are some terminologies. They are important here. These terminologies are important. So throughout the chapter, we are going to use these things. So we should be very clear about these terms here. So first, actually, here I have written the definition of Boolean algebra. So by this time you know already that this Boolean algebra is a section of the algebra or branch of algebra, or finally we can say this Boolean algebra is a section of maths which deals with only the binary number system, or else we can say it deals with only the logical values. So whenever we say logic, it's about only two states. Remember, it's a logic or Boolean. Okay, so here itself we know the other two names for the Boolean algebra is switching algebra and algebra of logic. Switching algebra in the sense it is switching between only two values, true or false or 1 or 0. That's why you can say it as a switching algebra, or you can say logical algebra. Logic means again it is about only true, false or 1 or 0. So that's why we parallelly these two can also be used for the Boolean algebra. So where Boolean algebra got its name because of this person, and here this bool name actually we have seen in first year C++ unit also, in the chapter also, or in the introduction to C++, if you can remember, in the basic data types. Okay, in the basic data types only we have seen this data type also. So basic data types we all know commonly normally using data types are these three: say int, float, char. So we are using these heavily in our programs, but actually there are few more are there in the basic data types. The double, okay, this void and this bool also. Okay, so we have studied this bool word even in this basic data types section of data types chapter in C++. And of course there I have given one small programming example where a variable is declared with this data type, bool data type. Then that variable can store either 1 or 0, not any other values. So there also we are using this bool word. So wherever it comes, the bool word, it is meaning of only two states, 0 and 1. And of course this is actually the person's name. Okay. So anyhow, coming to this terminologies here. So definition says that Boolean algebra is a branch of algebra and algebra is a branch of mathematics. Here we are going to deal with the logical values or binary number system. And binary number system we have studied where in the data representation chapter in the first year computer science. So now coming to this next binary valued quantities. So binary valued quantities are the quantities which having only 0 and 1. So when it is about quantities, it may be either variables or constants. So if you think of the algebraic expression, it's an expression where mathematical operators are used to combine the variables and constant values, or I can say numerical values, any expression. Say 2x plus 3.5. So it's a good algebraic expression. So where if variable is there, it may be any value, maybe a value which is belonging to the set real set, and if you are having any numerical values, they may be again they are belonging to this real set. But when it comes to Boolean algebraic expression, when expression is given to you, okay, there we can have only the logical operators, not any other operators, only the logical operators, because we are talking about Boolean. Boolean means logical algebra. Okay, So only logical operators we are going to see. This is nothing but or, and not. So when it's about Boolean expression, only the arithmetic operators we are going, logical operators we are going to see. When it comes to normal algebraic expression, it can have any mathematical operators, and the variables which can have any real value, and the numericals again they may be any value from plus infinity to minus infinity. But when it comes to Boolean expression, means Boolean algebraic expression, then there the operators must be logical operators. Then if the variables are there, they should be either 0 or 1. They are allowed to take 0 or 1, not any other value. Suppose if it is having any other value other than 0 and 1, then it will turn to be as normal algebraic expression. So I can consider this as Boolean algebra only x is having either 0 or 1. Whereas the other numerical values, they are already 1 and 0. So it's an example for Boolean algebraic expression. So only the binary values are allowed. So whether they are coming in the form of numbers or the variables. If variables are there, they should have either 0 or 1. So this is a logical expression. It's a normal algebraic expression. So here I have written the logical expression. It's about this one. Okay. So logical operators combined with the binary valued quantities. They may be variables with the binary values or numerical values which are binary values 1 or 0. Okay. So we have seen this one, and this binary logical expression is also over, and the logical statement, and it is even called as truth function. Compound statement is also called as logical function. So here in first year mathematics, okay, so we have seen a chapter called mathematical reasoning. Okay, so in a maths subject we have seen this chapter, mathematical reasoning. There we have studied about this statements, logical statements, the compound statements, and even we have learned about the and, or, not connectives, the logical operators there in this particular chapter. So that beginning topics of this mathematical reasoning helps us to understand these easily, okay, because they are basics, they are same here also. Anyhow, I will remind you about these things, starting from this logical statement. So there in this chapter actually it is about mathematical reasoning. Reasoning, when it comes, it has to be either true or false. So anyhow, we will see again those things. Logical statement. So in this particular chapter, mathematical reasoning, it all started with the statement. So a statement or logical statement, or you can say truth function. So given sentence can be accepted, it can be considered accepted as statement or logical statement if for that statement we can say either true or false. So such type of sentences are called statements. So usually the declarative type of sentences are the statements. So declarative sentence, if it is there, no doubt we can consider it as the statement or logical statement, because a declarative sentence, for that we can say either yes or no, or true or false. Okay. And for example, consider any declarative type of sentence. Say, sun rises in the east. Okay, so it's a declarative type of sentence. So it is going to be a statement. So for that sentence, we can say, everyone can say either true or false. So this statement is the correct statement. So the answer of this one is true. Others letter T indicates true. So this is one of the logical statement. Like this we can give many examples. Okay, so and here the statements result, whether it is true or false, they are actually called truth values. So for a given statement, means a sentence when it is accepted as a statement, it's going to have either true or false as its truth value. So it does not mean that truth value means it has to be true only. Truth value means it may be even false also. So truth value, it may be true or false. It's a result of the statement, the logical statement. So now coming to this compound statement, or the other name is logical function. So the definition is same what we have seen in mathematical reasoning. The compound statement is a result of combining two or more simple logical statements with logical connectives. So which are those logical connectives? And or not. Okay, so the definition is going to be same here also. So using these operators or the connectives, so we have used the word connectives in that particular chapter. So we can call them as operators also, because if you remember these three we have seen even in this computer science subject also in the first year. Okay, so where in the topic called operators. So in the operators topic we have seen in the computer science last year the operators, arithmetic operators, relational operators, logical operators. So there also we have seen and or not. So the property is going to be same wherever it comes, these logical operators. So wherever they are coming, the property is going to be same. So compound statements are the statements where these operators we are using to connect two or more simple type logical statements. So simple, or you can say component statements. When the compound statement is written, the individual simple statements we can call them as components of the compound statement. So as an example, if I say extend this statement, say if I write one more simple logical statements, say sun sets in the north. Okay, so this statement is also having the truth value because I am saying this as a statement already. So statement means it should have a truth value. So here this statement is not correct. So sun sets in the north is incorrect. So it should have this false as its truth value. So this statement, this simple logical statement, truth value is true. Its truth value is false. So what about the compound statement? Minimum we require two statements, okay, two simple statements. Then we can combine them using the logical connectives or logical operators. So here we are having two statements. Now we can combine these two. Say suppose if I have used the word and, okay, from here to here it's a compound statement now. And this is one of the logical connective or the operator. This is one simple statement, this is another simple statement, and totally it is compound statement. So two or more statements connected with logical connectives is going to be called as compound statement. So for the compound statement also, the answer is going to be either true or false. For that, we should know the truth values of individual components of the compound statement. So here sun rises in the east is true, okay, and this is an AND operator. and this one is false. Okay, and operator property, so what it states? It states that when all are true, then only it is true, otherwise it is false. Here all are not true, all means here only we are having two components, one is true, the other one is false, so finally it is false. So this is the result of the truth value of this compound statement. So to come to the truth value of a compound statement, we should know the truth values of all the components of that compound statement. Okay, so it is even called as logical function. So what about this binary division? So these all are over. Now this binary division. So binary division, the decision which results in either true or false is called binary decision. So for a sentence, if you say either true or false, or the decision which results in true or false or yes or no, then those decisions are called binary decisions. In the next video session, we will see again these and or not, which we already know in the last year maths chapter. Again we are going to see them in detail, and or and not operators. So that I will take in the next video session. Okay.